In physics in general, it's very important to be able to relate multiple quantities. Example, you should be able to relate force and velocity. Now, the way we connect force with velocity is using another quantity, which is acceleration. How can we do that? Acceleration has two formulas. Number one, acceleration is the change in velocity, where of course v is the final velocity, all right, and u is the initial velocity. So essentially, acceleration is the change in velocity. Change can be figured out by v minus u. Then you've got force, which is mass times acceleration. So you essentially have been able to relate both acceleration with the speed or velocity rather, and you've been able to relate it with force. So hence you can use these two formulas to relate force with the velocities. All right. Let's take an example of how. So the example says an object weighing 2000 newtons was accelerated by 4 meters per second squared. The object was accelerated from a speed of 12 meters per second for 6 seconds. So you've got this object weighing 2000 newtons, which was accelerated by 4 meters per second squared, means its speed increased by 4 meters per second every second. And the question says that the object was accelerated from a speed of 12 for 6 seconds. So for 6 seconds, its speed must have increased by 4 meters per second every second. All right, let's look at what the question's asking. A, find the accelerating force. B, find the final speed of the object. Now, without even having to figure out the accelerating force, I can easily figure out the final speed of the object. So let's do that first, and then we'll get to the accelerating force. So let's solve B first. All right. Now, I urge you to do that, to solve the easier parts first. Okay, so it does not necessarily have to be A, B, and then you solve C. If you can see that, okay, you can solve B first. You should just go ahead and do that. All right. So let's say, for example, you have this right here, the final speed of the object. We know 12 meters per second, which is the initial speed of the object. We know 6 seconds is the time. We know 4 meters per second squared is the acceleration. So it should be very easy to use the velocity and the acceleration formula to figure out the final speed. So A is equals to V minus U upon T. We are going to use this formula, A being 4. V we want to figure out. U is 12 divided by T, which is 6. 6 goes cross multiplies, so multiplied with 4 gives me 24, is equals to V minus 12. 12 goes over here, minus 12 becomes plus 12, so 24 plus 12 is now going to be equals to V. So that was part B. Now let's solve part A. Now we know the weight of the object. You want to figure out the accelerating force, you don't need the weight, you need the mass, right? You need the mass to figure out the force. So essentially in part A first, we need to figure out the mass of the object. So to figure out the mass of the object, now I'm writing this or I'm labeling my steps. You don't necessarily have to do that during your exams. So finding out the mass is very easy. W is equals to mg, where W, the question gives you the weight, which is 2000 newtons, is equals to mass times g, which is considered 10 meters per second squared, or you can take 10 newtons per kilogram. In that case, 0, 0 cancels out. So the mass is going to be 200 kilograms. So from this point, it generally becomes very easy. Force is equals to mass, which is 200 kilograms, times acceleration, which is 4 meters per second squared. So the force or the accelerating force on the object is 800 newtons. All right, so I hope that this made sense to everyone. So let's talk about a state in which a lot of the things around us are in, and that's the state of equilibrium. Well, the state of equilibrium just simply means that the resultant force on an object is 0. Well, what's the significance? The significance of the resultant force being 0 is that a lot of people think that resultant force being 0 means that there are no forces acting on an object. Well, that's wrong. That's simply wrong. Resultant force being 0 means that every force acting on an object is balanced. Balanced with what? Balanced with an opposite force acting in the same direction. All right. So you have a force, but there will always be a force present in the opposite direction to balance that force. This right here is just the first condition of equilibrium. There's another condition of equilibrium which we'll study when we'll study moments of force. But let's just talk about this with an example. You have a car traveling at a constant speed of 80 kilometers an hour. Now, is that car in equilibrium? So let's talk about this. Are there any forces acting on the car? Yes. There's the weight. There is, of course, the weight is balanced by the normal contact force. Now, of course, it's a car moving at a certain speed, so there has to be some amount of driving force. A car cannot travel. So, let's say, for example, if you turn off the engine of the car, of course, it's going to keep on slowing down until it comes to a stop. It cannot maintain a constant speed if the engine's turned off. So, there's always going to be a driving force. There's going to be air resistance, which is going to be the first backward force. And because the car is traveling on a road, there's going to be friction between the tires and the road surface. So there's two pairs. Number one is the vertical pair, which is the weight and the normal contact force, and they are going to balance each other out. So the vertical forces are balanced. Then you've got the horizontal forces, which is the driving force, the air resistance, and the friction. Air resistance and friction are backwards, driving force is forwards. But for a car to be in constant motion, there has to be no acceleration. And if there's no acceleration, there's no resultant force. And hence your horizontal forces are also balanced. That means that the resultant force on the car is zero, both in vertical and horizontal directions. So this right here is going to be it for today, kids. Inshallah, I'll see you in the next one. Bars out.